Hello all and welcome back to my YouTube channel. So today we are going to see a very interesting project where we will be classifying a vest with the help of Azure AI Custom Vision. And why exactly we have chosen this particular product, because there is a lot of demand going around in the world where the governments are putting a lot of efforts in using artificial intelligence in doing the waste classification, identifying the types of different waste and then using it for recycling. So I thought it's a good opportunity. So let's build a project with the help of Azure AI Custom Vision, because that provides a very flexible platform and will be able to rapidly build the computer vision AI models. So if you are new to the image classification and computer vision, so computer vision is a branch of artificial intelligence, and image classification is a technique which is used to identify the labels, classes of image and segregate the images as per the classes. So there are multiple real-time use cases where the image classification is used. There are other techniques available in computer vision like image segmentation, object detection, image captioning. But in today's video, we are going to see the image classification because that is a bit simple technique to understand. So we'll get started with image classification, and in further videos, I would like to cover the remaining techniques as well. So let's understand what are the different real-time use cases that where the currently this particular image classification is getting used. So there are several authentication systems where the image classification is used to identify whether the entered person into the society or entered into the office is the right person or not. So with the help of face IDs, it is detecting and classifying the images, and based on that, it is allowing the user to enter into the office or whatever is the system. There are other areas like medical where the like in medical diagnostic, the image classification is highly used in order to identify several diseases. So if these with the help of image classification models, by analyzing the tumor images, the models are helping the doctors to identify the stage of cancer or whether the person is suffering from cancer or not. So it is getting widely used in detecting the cancerous patient. Also, in quality controls in the organizations, it is used in order to identify the defective parts, segregate the defective parts out of the good quality parts. So there are tremendous applications, and in today's project we are going to see how the garbage is getting classified, how we can classify the garbage with the help of image classification model. So this particular model will classify the garbage. There are multiple categories like plastic, metal, organic, paper, or cardboard. So those waste we will be classified into the different categories, and accordingly later on we can extend this particular project in order to build the complete end-to-end automation. So, but you might be asking one question: why AI Custom Vision only? Why Azure AI Custom Vision? Because it is very simple, and you can perform a rapid training with the help of Azure AI Custom Vision. And again, it is a service provided by Microsoft, so it provides scalability. You can easily scale up your services based on the demand. And if you have minimum number of images available with you, still these models will work, because these are the pre-trained models which are trained on already trained on the global data that is available, and that's where you no need to provide lot many images in order to train your model. So if you are familiar with computer vision, then you might know that earlier it used to take a lot of times in order to build or train a computer vision models. Though it is image classification or object detection, we need to use transfer learning in order to save our time or in order to improve the accuracies. And the earlier models used to be very bulky, heavy models, so we need to download those models, set up that onto our local, and that's how it becomes very complicated process. And we used to face a lot of errors while building these models as well. But now it becomes very simple with the help of Azure AI Custom Vision, because it provides a no-code platform, a web portal platform where you can upload your images and you can directly train your model. All the compute power that is required to train the model, all the resources will be provided by Azure. And yeah, again, this portal is very easy to access. So without wasting much time, let's get straight into the project. So Okay, so I have logged into my Azure portal. So you can go to portal.azure.com, and in order to create the custom vision service, you need an active Azure account. So to create the Azure active account, you can either use a free account service. If you are logging in for first time, it gives, I think, worth 200 credit for you that you can use, or you can register and select pay as you go service. So currently I'm on pay as you go service, but yeah, there are several limitations with free service. Few of the services are not available under free subscription, so please just look into that and accordingly select the subscription. So in order to get start with, what you can do, you can search a custom vision. So this is the service that we will be using. Now there are two services that we need to create. One is the training service and another is the prediction service. So I have already created these two services, so I'll show you how exactly we can create. Now for this particular service, you can create a free tier account. So you can see here the pricing tier for these particular two services is F0, meaning the free tier. So you can create one free tier service, and inside that service you can create two free projects. So I'll show you once we go ahead. That's where I'll be using this, but I'll show you how you can create this service. So you can click on create. Once you click on create, here you can see create options. You need to select both because we need prediction training both. First we will be training the model, and later on we will be predicting the images as well. So we will be predicting the results, so that you can select. Subscription, I have this particular subscription. Resource group, you can create new resource group of, or if you have any existing resource group, you can select that. And then region, select East US. There are limited regions under which this particular service is available, so make sure you are selecting East US. Then you can give any name, like I take vision, something like, you give the name. And then you can select pricing tier. So in pricing tier, currently I have standard F0 because I have already utilized the free service. So for you here, it will be F0. Select that F0. And similarly for the prediction, you need to select the F0. So that you will be able to select once you have created the service for first time. And then you can click on review and create. Once you click create that, the services will be created for you. So I'm discarding it because I already have. So these two services we will be using. Now, once the services are created, our next step is we can go ahead to the custom vision API. So you can type customvision.ai. That will take you to the custom vision AI portal. And you can see you can create a new project. So let's create the new project. Let's give the name as garbage classification. Description is, add some description, classifying images. And here you can see now the resource that is available. So here from the Azure subscription, we can select this F0, that is free resource. So I'm selecting that free resource. And project type, because we are going to ahead with the classification, so select classification. Then here classification types, multi-label or multi-class. Multi-label meaning in single image you have multiple tags, like in a single image you have let's say glass, you have metal trash. So in the single image, if you have those multiple items, then you can we can select multi-label. But for us, we have the multi-class. So I'll show you the data. Domains you can keep general, and let's hit on create project. Okay, now the project is created. Now it's time to add the images. So you can see here the option is there to add the images. Okay, so we have two datasets, train and test. So for training, let's add the train dataset, and these are our categories: cardboard, then we have glass, metal, paper, and plastic. So I'm selecting cardboard first. Let me select all the images. So for each class, I have kept 15 images. Let me open those. And here you can add the tag for that. So tag is the cardboard. Hit upload. Okay, images are uploaded, done. And you can see with 15 images, we'll be able to train a image classification model, and I'll show you the accuracy as well. It will work very good. So once this is done now, next step is, so you can see now we have created 75% of the task. Within just 2 minutes, we have completed 75%. So create project is done, upload images is done, tag your images, that is also done. Now we need to upload the another tag images. So let's click on again add image. Let's go back. Let's select glass. Let's open glass and add tag as glass. So let me quickly go ahead and upload the remaining classes as well. Okay, you can see I have uploaded all the classes: cardboard, glass, metal, paper, and plastic, and each we have kept 15 images per class. Now, next step is we are done now. We just need to select and we need to start the training. In order to start the training, we have this particular option to start. So let's click on that. And here there are two options: advanced training, which takes a lot of time. So if you select advanced training, you can define the training budget, how much for how much time you want to train that. And it is mostly suitable when you have a lot of images with you. And in those cases, you can go ahead with that. But for us, let's go ahead with quick training. And it is saying minimum budget 1 hour, meaning it should be done within 5 minutes. But let's see. So I am starting the training. So now you can see the training has started. You can see iteration 1 is going on with the training and last check it has given. Now once the training is completed, we'll see the model available here and then we can use that model for prediction. So let's wait for the training to get complete. Okay guys, you can see now the training is completed and it took close to 4 to 5 minutes for me to complete the training. And you can see the accuracy matrices. Precision it is 84%, recall 73%, and average percentage is 86%. So uh, it is working pretty good. Like still we had only 15 images per class. Still we have achieved the good accuracy, and you can see the accuracy per tag. So across these 5 tags, this is the particular accuracy. So I think it is making mistake in predicting plastic and glass because they look very much similar, and that's where it is making some mistakes. But yeah, if you increase your data set, definitely it will work very good. Okay, so now the time is for prediction. So we have prediction section available here. So let's go to the prediction. So in the prediction, you can see there are options available like view endpoint. With the help of these endpoints, you will be able to use these particular models into your local. So currently it is saying that the model is not published. First we need to publish the model. So we'll publish the model and then it will be available. But before that, let's go ahead and quickly test the model. So for testing the model, you can see we can upload the test images now. Either you can enter a image URL or you can browse the file from the local. So let's go ahead and we have test folder created. So from test we'll pick up image. So this is cardboard image. So let's see what it is classifying. So okay, you can see it is classifying cardboard as 99.5% probability, meaning it is doing the classification correctly. Let's try with another model. Sorry, let's try with another image. Let's upload the glass image and see. Okay, see glass still it is saying 60% accuracy. So even though the accuracy for glass and plastic was a bit less, but if you are adding 50% threshold, still it will do the correct classification. And I would recommend use more training images because 15 is very less number. So within that, if we are getting this level of accuracy, meaning it is working very good. Let's test one more image. So this is plastic. So you can see 91% it is saying plastic. Let's test some metal. Let's see what it is predicting. You can see metal it is predicting 89%. So this is the can actually. That's where it is saying metal. So isn't it amazing? Because behind the scene, right, there are pre-trained computer vision models that it is using. The Azure Custom Vision is using, and that's how within the very limited sample data, it is able to build these models very easily. It is able to build these powerful models. Now you can see in the predictions, you can see whatever we predicted, those prediction results are available here. In order to publish the model, we can go to the training image section. Sorry, in the performance section, you can see there is option available to publish the model. So once we click on publish, it is saying give the model name. So we'll keep that model name, and the Azure subscription we need to select for prediction. So if you remember at the time of creating the Azure subscription, sorry, at the time of creating the custom vision service, we have created training and prediction. So this prediction is used for prediction purpose, and then we can publish. So you can see now the model is published. Once the model is published, you will be able to consume these models into your deployed or any production or any other environment. So let's say you can, with the help of SDK, you will be able to consume these models into your local. And in order to fetch those details in the predictions, you will see, sorry, you can see here the prediction URL is available. So these are the details like prediction URL that you can use and the prediction key in order to access these models and in order to do the prediction in your local. Okay, so let me show you how you can use these models into your local. So I'm jumping into the VS Code. So this is the code that I have written. So let's see what exactly it is. So we are using these API credential in order to access the credentials and the Azure Cognitive Services. So this is the particular service that we will be using, custom vision prediction chart, in order to do the prediction. For training, we will use training. So here we will be seeing how we can predict it. Now we need these details, like we are loading the environment configuration, and then we need these details, like we need project key, endpoint, project ID, publish name. So all these details I have kept it into the environment file, but I'll show you from where you can get those details. So for prediction key, you can get it from the prediction URL. So in the performance tab, if you click on prediction URL, this is your prediction key. Sorry, this is your prediction key. Now we are reading an image file. If you are using image URL, you need to use these key and that this particular endpoint. But as we are testing it over the file, so we are using this particular key. So this is our key. Then this is our URL. So URL, we need to take it till this particular point, the prediction.cognitiveservices.azure.com. Above that, you can skip it. So let me show you where I have added it. So you can see this is the key, then endpoint I have added till the .com and then slash. Now project ID, to get the project ID, you can click on this setting, and in the setting, you can see this is your project ID. So that's what I have given here, and the model name. Model name, you can again get it from the performance tab. So this is the model name, iteration 1. That is iteration 1. So we have added all the secrets. Now what we are doing is we are building the connection. So with the help of this particular client, we are building the connection. Then we are reading the image. So from the data, we have test, and in the test, I have put those test images. So we are reading this class 62 image, this particular image. Then we are calling a prediction client, and with the help of prediction client, we are passing project ID, published name of model, and the image data. This is particular image data, and when we are passing, it is generating the result. So this is already predicting. Now the prediction is done. Whatever code that is available below is used for printing that particular prediction. So I have used PIL library, the pillow library, in order to print the results, so that I can show you how exactly it is printing. So this particular code is for that purpose only. So you can see this is the font that I have given in order to show on the predicted image, and this is the final prediction confidence. If it is greater than 50, then only we are showing the prediction score. So let's go ahead and execute this. So I have already attached the requirements.txt. So these are the requirements required. So whenever you are cloning this particular repo, the link will be available in the description below. So you can clone the repository. You just need to install these dependencies, pip install -r requirements.txt. You need make sure you are creating a virtual environment. In order to save the time, I have already created that. So let's go into the main.py and let's execute that. Python main.py. Now we are predicting this particular image, class 62.jpg. Okay, you can see it has predicted glass at 61 percentage, and this is the image. You can see the prediction glass 61 percentage and the image. So isn't it cool? Now the model is hosted on your Azure AI platform. You are only connecting to that model. You no need to download those heavy models into your local in order to do the prediction. And that's where it becomes very easy nowadays to build the classification or detection or computer vision related problems. Sorry, projects. Okay, let's move ahead. We can test one more image. So from the data test, this time let's select paper. So let me copy the relative path. Let's execute this now. So it should classify the image as paper. Okay, you can see it is predicting paper as 99%. So it is working as expected, and it is very simple. You can see the code is hardly of 20 lines, because after this, right, hardly 25 lines. After this, it is only for the code written only for showing you the predicted image. You can see the image will be stored into this predicted folder, so you can access the image from here as well. But yeah, within just 25 lines of code, you are able to load the computer vision model, and that you have trained on your custom data. So I hope this was helpful for you. And the reason I picked this particular project is because I already told you the government is now focusing more on using AI tools in order to do the garbage classification. So this was just the small project. So if you like this particular project, please go ahead and like the videos, share it with your friends, and subscribe to my YouTube channel. And if you want a few more real-time projects, please ping me down in the comment section. I'll see you soon in the next video. Thank you so much.